Yes, it is standard practice to use multiple current transformers, or CTs, in parallel to monitor heat loads in some metering applications. Parallel CT offer several benefits. Firstly, increased current range. Parallel CT allow for a wider current range to be measured. By effectively increasing the number of turns in the primary circuit of the CT configuration, the rated current capacity of the system is also increased, enabling measurement of higher loads. Secondly, improved accuracy. Multiple CT in parallel provide redundancy, which can improve accuracy by reducing the impact of any individual CT failures or errors. This redundancy ensures more reliable and consistent measurements. Thirdly, cost optimization. Using multiple smaller CT in parallel can sometimes be more cost-effective than using a single large CT with the required capacity. The impact on net load calculation is such that parallel CT do not reduce the net load calculation. The current from each CT is summed together to provide the total current, which is then used to calculate the net load. The net load is calculated using the formula net load equals voltage multiplied by the sum of CT currents. To illustrate with an example, if two CT are used in parallel, each with a rated current of 100 amps, and they each measure 50 amps, the net load calculation would be net load equals voltage multiplied by the sum of 50 amps plus 50 amps, which equals voltage multiplied by 100 amps. This is the same net load that would be calculated if a single CT with a rated current of 100 amps were used. Additional considerations are that the CT must be properly sized and matched to ensure accurate measurements. It is essential to select CT with appropriate ratings and characteristics for the specific application. The polarity of the CT must be correct to ensure that the current flows in the same direction through each CT. Incorrect polarity can lead to inaccurate measurements or even damage to the metering system. Proper wiring and calibration are essential to maintain the accuracy of the metering system. Ensure that all connections are secure and that the system is calibrated according to the manufacturer's instructions. When implementing parallel CT, several key factors must be taken into account to ensure accurate and reliable measurements. Firstly, CT selection. Choose CT with identical ratios, burden ratings, and accuracy classes. Mismatched CT can introduce errors due to differing responses to the same current. Secondly, wiring. Connect the CT in parallel carefully to ensure proper polarity. Incorrect polarity can cause circulating currents and inaccurate readings. Verify the polarity markings on each CT and follow the manufacturer's wiring diagrams. Thirdly, burden impedance. Ensure that the total burden impedance seen by each CT is within its specified range. Too high an impedance can reduce accuracy, while too low an impedance can overload the CT. Fourthly, calibration. Calibrate the entire system, including the CT and metering equipment, to ensure accurate measurements. Use a known current source and compare the measured output to the expected value. Fifthly, monitoring. Regularly monitor the performance of the CT and metering system to detect any signs of degradation or failure. Check for loose connections, corrosion, and other potential issues. Sixthly, safety. Follow all relevant safety precautions when working with CT and metering equipment. Use appropriate personal protective equipment and de-energize circuits before making any connections or adjustments. In summary, using parallel CT for heat load metering is a standard practice that offers several advantages, including increased current range, improved accuracy, and cost optimization. However, it is crucial to carefully select, wire, and calibrate the CT to ensure accurate and reliable measurements. By following these guidelines, you can effectively monitor heat loads and optimize energy consumption. The voltage used in the net load calculation refers to the voltage at the point where the current is being measured. This is typically the line voltage of the electrical system. For example, in a 480-volt system, the voltage would be 480 volts. The sum of CT currents represents the total current flowing through the parallel CT. This is calculated by adding the current measured by each CT. For example, if two CT are used in parallel and each measures 50 amps, the sum of CT currents would be 100 amps. The net load is the total power being consumed by the load. This is calculated by multiplying the voltage by the sum of CT currents. For example, if the voltage is 480 volts and the sum of CT currents is 100 amps, the net load would be 48,000 volt amps, or 48 kilowatts, assuming a power factor of 1. The accuracy of the net load calculation depends on the accuracy of the CT and the voltage measurement. It is important to use high-quality CT and voltage measurement equipment to ensure accurate results. The location of the CT can also affect the accuracy of the net load calculation. The CT should be installed as close as possible to the load to minimize the effects of line losses. The calibration of the CT is essential for accurate measurements. The CT should be calibrated regularly to ensure that they are measuring current accurately. The frequency of calibration will depend on the specific application and the manufacturer's recommendations. The wiring of the CT must be done correctly to ensure proper operation. The CT should be wired in parallel with the same polarity. Incorrect wiring can lead to inaccurate measurements or even damage to the equipment. The burden impedance of the CT must be matched to the metering equipment. The burden impedance is the impedance that the CT presents to the metering equipment. If the burden impedance is not matched, it can lead to inaccurate measurements. The operating temperature of the CT can affect their accuracy. The CT should be operated within their specified temperature range. Operating the CT outside of their temperature range can lead to inaccurate measurements. The presence of harmonics in the current can also affect the accuracy of the net load calculation. Harmonics are non-sinusoidal components of the current. If harmonics are present, it may be necessary to use a true root mean square meter to accurately measure the current. The type of load being measured can also affect the accuracy of the net load calculation. For example, if the load is highly inductive or capacitive, it may be necessary to use a power factor correction capacitor to improve the accuracy of the measurement. The use of parallel CT can also introduce additional errors. These errors can be minimized by using high-quality CT and by carefully following the manufacturer's instructions for installation and calibration. The maintenance of the CT is essential for accurate measurements. The CT should be inspected regularly for damage or corrosion. Any damaged or corroded CT should be replaced immediately. The documentation of the CT and metering equipment is essential for troubleshooting and maintenance. The documentation should include the manufacturer's specifications, wiring diagrams, and calibration records. The safety of personnel is paramount when working with CT and metering equipment. All safety precautions should be followed to prevent injury or death. The training of personnel is essential for the safe and effective operation of CT and metering equipment. Personnel should be trained on the proper procedures for installation, calibration, maintenance, and troubleshooting. The compliance with applicable codes and standards is essential for the safe and legal operation of CT and metering equipment. The codes and standards may vary depending on the location and application. The selection of the appropriate CT for a given application is critical for accurate and reliable measurements. The selection process should take into account the following factors. Firstly, a maximum current to be measured. The CT should be rated for the maximum current that will be flowing through the circuit. Secondly, the accuracy class. The CT should have an accuracy class that is appropriate for the application. Thirdly, the burden rating. The CT should have a burden rating that is compatible with the metering equipment. Fourthly, the insulation voltage. The CT should have an insulation voltage that is appropriate for the voltage of the circuit. Fifthly, the operating temperature range. The CT should have an operating temperature range that is appropriate for the environment in which it will be installed. Sixthly, the physical size and shape. The CT should be physically sized and shaped to fit in the available space. Seventhly, the cost. The CT should be cost-effective for the application. The installation of CT should be performed by qualified personnel. The installation process should follow the manufacturer's instructions and all applicable codes and standards. The CT should be installed in a location that is accessible for maintenance and inspection. The CT should be protected from physical damage and environmental conditions. The wiring of CT should be performed by qualified personnel. The wiring process should follow the manufacturer's instructions and all applicable codes and standards. The CT should be wired in parallel with the same polarity. The wiring connections should be secure and properly insulated. The calibration of CT should be performed by qualified personnel. The calibration process should follow the manufacturer's instructions and all applicable codes and standards. The CT should be calibrated regularly to ensure that they are measuring current accurately. The calibration records should be maintained for future reference. The maintenance of CT should be performed by qualified personnel. The maintenance process should include regular inspections for damage or corrosion. Any damaged or corroded CT should be replaced immediately. The maintenance records should be maintained for future reference. The troubleshooting of CT should be performed by qualified personnel. The troubleshooting process should follow the manufacturer's instructions and all applicable codes and standards. The troubleshooting records should be maintained for future reference. The disposal of CT should be performed in accordance with all applicable regulations. The CT may contain hazardous materials that require special handling and disposal procedures. The use of parallel CT can be a cost-effective way to increase the current range of a metering system. However, it is important to carefully select, install, wire, calibrate, maintain, and troubleshoot the CT to ensure accurate and reliable measurements. The use of parallel CT should be considered in the context of the overall metering system design and the specific application requirements. It is important to consult with qualified professionals to determine the best approach for a given situation. The accuracy of the current transformers is usually expressed as a percentage. For example, a CT with an accuracy of 0.2% will measure the current within plus or minus 0.2% of the actual value. The accuracy class of the CT should be chosen based on the requirements of the application. For critical applications, a higher accuracy class CT should be used. The burden rating of the CT is the maximum impedance that can be connected to the secondary winding of the CT without affecting its accuracy. The burden rating is typically expressed in volt-amps. The burden rating of the CT should be compatible with the impedance of the metering equipment that is connected to it. The insulation voltage of the CT is the maximum voltage that can be applied to the CT without causing it to break down. The insulation voltage of the CT should be greater than the voltage of the circuit in which it is installed. The operating temperature range of the CT is the range of temperatures over which the CT will operate within its specified accuracy. The operating temperature range of the CT should be appropriate for the environment in which it is installed. The physical size and shape of the CT should be compatible with the available space in the installation. The cost of the CT should be considered in the context of the overall cost of the metering system. The selection of the appropriate CT for a given application is a complex process that requires careful consideration of all of the factors discussed above. It is important to consult with qualified professionals to determine the best CT for a given situation. Proper installation, wiring, calibration, maintenance, and troubleshooting of CT are essential for accurate and reliable measurements.